Sorry guys, my last video got cut off. I got kind of a camera that, I don't know, gives me some issues sometimes, kind of finicky. So we were talking about homework problems, and this is for 8-1. We just talked about the interior angle sum theorem and the exterior angle sum theorem. So I'm going to go through a couple of these problems to get you started. Okay. From this section, the problems we're going to do are 13 through 16, 21 through 24, and 36 through 40. They're not very hard, but I do want you to show your work, and I'm going to give you, again, a couple examples, just in case you missed class today, or you just wanted somebody to kind of help you get started. Okay? All right, let's start with 13. So the directions say, find the sum of the measures of the interior angles of each convex polygon. All right, so we actually have a theorem, which is kind of a formula almost. I mean, it is still a theorem, but the measures of the interior angles of a convex polygon, the sum of the measures is 180 times n minus 2, right? So all we got to do is figure out the number of sides. In 13, it says it's 32 gon. A 32 gon is 32 sides. Okay, so we have 180 times 32 minus 2. Remember that there's 2 less triangles that you can draw than the number of sides. If there's 32 sides, you can draw 30 triangles inside. So this is going to be 180 times 30. I want you to set up your equation because I want to see that you know that fact, right? If you just put a number here, I don't know where you got that number. You could have got it from the back of the book, you could have got it from your friend, whatever. If you show me this, you show me, first of all, you know the theorem that you're talking about, and you know how to substitute the parts in where they go. Okay, so I want to see this kind of stuff. You got 180 times 30. So write out the equation, go as far as you can go, and then at the very end, when you got it kind of all simplified, then you can write your final degree measurement. Okay, so show your work. All right, so that's not too hard. Find the sum of the measures of the interior angles of each convex polygon. Again, that's just a kind of a straight formula. Okay. Let's look at another one here. These ones are a little bit more tricky. I'll show you how to set one of these up. Okay? I'm being really gentle with my camera because it sometimes will automatically unplug on me. And then I got to start over. All right, so these guys here says the measure of an interior angle of a regular polygon is given. Find the number of sides in each polygon. Okay. Now there's a couple things going on here. Okay, first off, we got a regular polygon. Okay, here we have a convex polygon. So what's the difference? Well, remember that regular means that it has all the angles are congruent. All the angles are the same. Okay, so that's one idea. Okay, the other idea is that this is one of the angles. It's not the sum of all of the angles, it's one of the angles. Okay, so let's see if we can kind of figure this out really quick. Okay, I'm going to go ahead and write this above 21, but, you know, you can write this in your notes if you want to. Sum of interior angles equals 180 times n minus 2. Okay, that's not new. We already knew that, right? But what if you wanted to find one angle in a regular polygon? Now, this is true for any convex polygon. But if you kind of assume that the angles are all the same, this is all the interior angles, what you could do is you could just divide by the number of interior angles. So here's the sum of all the interior angles. If you divide this by the number of angles, then you're going to get the measure of one angle, one interior angle. So for one interior angle, for a regular polygon, remember it has to be regular, otherwise this doesn't work. You take the sum of all the angles and you divide it by the number of angles, and you get that one angle. Okay? Let me give you an example of how that's going to work. So let's do one angle of a regular hexagon. This is going to set up number 21 for you. Okay? One angle of a regular hexagon. Okay. So if we do the sum of angles in hexagon, and let's make sure they're interior angles, it's going to be 180 times 6 minus 2, right? Just like we did in number 13. Okay, so in this case, that would be 180 times 4, or 720. So the sum of the interior angles is 720, right? But what if you wanted to know just one of them? Let's assume it's a regular hexagon. Let's assume that all the angles are congruent to each other. Well, you take that 720 and you divide it by 6, right? So if you take the sum and you divide it by the number of angles, you would get the angle measurement for one, assuming that it's regular, right? So let's do 720 over 6. Let's see what that comes out to be. Okay, that's 120 degrees. These are all 120. Okay, now that concept, this idea is what we're going to use. This is what we're going to use for number 21. Okay, so 21 says, hey, I'm going to give you the angle. I'm going to give you this guy. You tell me how many sides it must have. Okay, so we're going to use this idea and we're kind of going to set it up. So 140 degrees is the measure of one angle for this regular polygon. We don't know how many sides it have, right? But if we did, what we do is we do 180 times n minus 2, and that would give us the sum of all the angles inside. Okay? We have to take that and we have to divide it by how many angles there are, because this is the sum of all the angles. We divide it by the number of angles to get just one. We don't know how many sides there are, but we do know that one of those angles is 140 by itself. So this is the setup for a problem like 21. And you're going to use the same setup for 22, 23, 24. Right? Same idea. We just got to solve for n. So what you're going to do here is you're going to multiply by n on both sides. Okay, you're going to get 140n. And on the left, on the right, these are going to cancel. And so you get 180n minus 2 in parentheses. Okay? So if you simplify the right-hand side by distributing the 180, you get 180n minus 360. Sorry, let's put an n on that 180. 180n minus 360. And now we're just kind of try to group the like terms. So I'm going to subtract 180 from both sides. I'm going to get negative 40n equals negative 360. And I'm going to divide both sides by negative 40. Okay, that's going to give me 9 sides. So n is equal to 9. So it's a nonagon. Okay, so this idea is what you're going to use, right? For one interior angle in a regular polygon, what you need to do to find that is you do 180 times n minus 2. That's the sum of all the interior angles. You have to divide that by the number of angles, which is also the same as the number of sides. Okay, so this right here is how you get the measure of one of the interior angles if it's a regular polygon. Okay, if you don't know how many sides, but you know the measure of one of those angles, you can find out how many sides by working backwards. Okay, so that's 21 through 24. That will help you with that. Okay, let's take a look at one from the back. All right, the last section you're going to look at here is this section here. You got 36, 37, 38, 39, and 40. So a couple from this section, a couple from this section. And the directions are pretty similar. We want to find the measures of one exterior angle and one interior angle, they're all the same, so each, for a regular polygon, right? So regular polygon, we're talking about all the angles and all the sides. All the angles are congruent, all the sides are congruent. So let's do number, let's do 38. Okay, so we're talking about an octagon. That's 8 sides. Okay, if we have the sum of the interior angles, it's 180 times n minus 2, right? The sum of the exterior angles is equal to 360, and that's always the case, remember? For any convex polygon, the sum of the exterior angles is always 360. For the interior angles, it depends on how many sides there are. Okay, let's go ahead and finish the interior angle since we don't have this yet. So 180 times 8 minus 2, or 180 times 6. Okay, so that's going to be 30 degrees for each interior. Oh, excuse me, sorry. I did something wrong here. 180 times 6. Sorry about that. It's 1080. 1080. Okay. Now that's the sum, right? This is the sum of all the interior angles. This is the sum of all the exterior angles. If you want just one of them, first of all, you have to know that it's regular. If it's not regular, you don't really know that they're all the same size and you can't really divide. But if you do know they're all the same size, you can just divide by the number of sides, right? So 1080 is the sum of all the interiors, and you divide it by the number of sides, which is the same as the number of angles. Okay, so this is the sum of the interior angles, but there's 8 of them. So when you divide by 8, you're going to get each one is 135 degrees. Let's label this as interior angle. Okay, each interior angle is 135 degrees. Okay, let's do the exterior angles, right? We know the sum is 360, but remember there's 8 of them. So we want to find each one. We're assuming that they're all the same because of that keyword regular. Okay, so exterior angle, each one's going to be 45 degrees. Okay, once again, remember to show your work. Show me what you're doing. Show me that you understand by setting up equations, by applying theorems, writing out what you're doing so I can follow your chain of reasoning. Okay, the rest of these are going to be similar. Okay, so you'll kind of follow those patterns. That's kind of one problem from each section. That should help you get going there. Now, don't stop there because we have one other section we covered today. We didn't cover a whole lot of it in class, and so I'm going to go through a little bit of that in the next video for you.